are falling. Ahead of you hangs a wound in space itself, a sphere of perfect darkness ringed by a halo of shredded, glowing light. This is a black hole, and you have already passed the last orbit from which return was possible. In the next few seconds, everything you know about up and down, past and future will be rewritten. And there is nothing, anywhere in the universe, that can pull you back. Below you waits the event horizon. Not a wall, not a surface, but a boundary drawn in mathematics. Cross it, and to escape you would need to travel faster than light, which nothing can do. The strange thing is, you feel nothing as you pass. No barrier, no jolt, no alarme. You sail through the most consequential line in the cosmos without the faintest sensation that anything has changed. But far behind you, someone is watching, and they see something impossible. To them, you never actually fall in. You slow, you redden, you dim, your final moment stretched across eternity until you fade like an ember into the dark. Two observers, one event, two irreconcilable truths. Which one is real? Follow us past the point of no return, second by second, to the place where physics itself comes apart. To survive long enough to tell the story, you need the right monster. Fall into a stellar black hole, a few times the mass of our sun, and you would be destroyed long before reaching the horizon. So instead you choose a supermassive giant, millions of times heavier, lurking at the heart of a galaxy. This horizon is so vast that crossing it feels gentle. But a question is already forming. If this thing is so enormous, what exactly is doing the killing? As you plunge inward, the universe begins to warp. Light from the stars behind you bends around the black hole, wrapping the darkness in a ring of distorted fire. Your clocks still tick normally to you. A second is still a second. Yet time itself is stretching. The deeper you go, the slower your seconds run compared to the world outside, though you will never feel it happen. Your speed climbs relentlessly. There are no brakes here, no friction to slow you. Only the pull, growing with every kilometer. You are already moving at a sizable fraction of light speed, and the great disk of fire ahead compresses into a blinding arc. Behind you, the entire visible universe is being funneled into a shrinking window of light, as if you were falling down a well made of stars. Around the black hole spins a disk of superheated gas, torn from stars and clouds that wandered too close. Friction whips it to millions of degrees, and it blazes brighter than entire galaxies before vanishing over the edge. You fall through the storm of X-rays and light, the last luminous thing you will ever see. Ahead, the darkness is no longer a shape in the sky. It is the whole sky. The moment arrives. You cross the event horizon. There is no fanfare, no flash, no boundary you can point to. Space and time simply trade places. From here, the singularity at the center is no longer a location you could steer away from. It has become your future, as unavoidable as tomorrow. You could fire every engine ever built, and you would still fall inward because inward is now the only direction time allows. Could you send a warning back to your crew? You try. You aim a radio signal, a laser, a desperate shout of light back toward the stars. But no signal can climb out of the horizon. Escape would demand a speed the universe forbids. Your message races outward and still falls in with you. This is why we call it a black hole. Not a place that hides light, but a place light can never leave. And here is the cruelest trick. Because time bends so severely, you can still look up and see the outside universe, but now it races forward. Stars wheel and die, galaxies drift and dim, the future of everything unspooling above you in fast forward. You are watching eternity pass in your final seconds. And yet, to that distant observer, you have not fallen in at all. Both of you are right. Hold on to that contradiction, it will matter. Now, the answer to what does the killing? It is not the darkness, nor the crushing depth. It is the difference in gravity between your head and your feet. Close to the center, that difference grows monstrous. Your feet, nearer the singularity, are pulled harder than your head. You begin to stretch. Physicists gave this gruesome process a name almost too playful for what it does: spaghettification. At first it is gentle, a faint tension head to toe. Then it accelerates without mercy. You are drawn into a thread, thinner and longer, while the same force squeezes you inward from the sides. Your body, then your cells, then your very molecules are pulled into a stream of matter falling toward a single point. In the span of a heartbeat, the traveler becomes a ribbon of atoms. Strangely, for most of the fall you feel weightless. In free fall, gravity is not a force pressing on you but the very shape of the space you drift through. So you sense nothing pulling until the tides grow uneven. That is the quiet horror of it. There is no warning tremor, no rising pressure, only a serene descent, right up to the moment your own body is torn along its length. How long does it last? For a supermassive black hole, you cross the horizon intact and fall freely for seconds, even minutes, before the tides sharpen. For a small one, spaghettification would finish you before you ever reach the edge. Size decides everything. The bigger the beast, the deeper you travel, and the longer you remain yourself before the end. But that end is coming, and it has no bottom. What waits at the center? This is where the story slams into the limits of human knowledge. Our equations say all the mass funnels into a single point of zero size and infinite density, the singularity. But infinity is not an answer. It is a sign that the mathematics has broken. When general relativity predicts infinity, it is really confessing that it no longer knows what it is talking about. Here, the two great theories of physics collide. General relativity governs the very large, stars, galaxies, gravity itself. Quantum mechanics rules the very small atoms and particles. At the singularity, something unimaginably massive is crushed into something impossibly small, and both theories must speak at once. They cannot. Their answers dissolve into nonsense. To describe your final instant, we would need a theory of quantum gravity that no one has yet written. Some physicists suspect the singularity is nature's way of hiding its own ignorance, that a deeper theory would smooth that infinite point into something finite and strange. Others wonder if the interior conceals a gateway, a bridge, or a region where cause and effect lose their grip entirely. These are not idle dreams but serious frontiers of research. Every black hole is a sealed laboratory running an experiment we can never observe and never repeat. So we must be honest. No one knows what truly happens to you now. Perhaps you are crushed out of existence. Perhaps the singularity is not a point at all, but a doorway our physics cannot read. What we can say is that the traveler's journey ends where our understanding ends, at the same instant in the same place. You have fallen off the edge of the map. Now return to the one who stayed behind, still watching through a telescope. Remember, they never saw you fall in. To them, your descent slowed as you neared the horizon, your image reddening and dimming as your light fought harder and harder to escape. You froze at the edge, a fading photograph pinned to the surface of the black hole, growing dimmer for millions of years but never quite gone. So which is true? Did you plunge to the singularity in seconds, or hang frozen at the horizon for eternity? Astonishingly, both. There is no master clock in the universe, no single now that everyone shares. Your time and their time are simply different, and neither is the lie. Two truths, contradictory yet equally real, separated forever by the one line you can cross but never uncross. This is why a black hole is less a place than a promise the universe makes about time. To you, it was the swiftest of deaths. To the cosmos, you became a permanent fixture, your last light bleeding across ages. Neither view can be reconciled, because there is nothing above them both to decide. The traveler and the observer live in different rivers of time, and those rivers will never meet again. But this is not quite the end, because the black hole itself is dying. Slowly, over spans of time that dwarf the current age of the universe, it leaks the faintest glow, hawking radiation, particles escaping from the very edge of the abyss. Grain by grain, the monster evaporates. And when the last black holes finally wink out, trillions upon trillions of years from now, the darkness that swallowed you will be gone. And this raises the deepest riddle in physics. Quantum theory insists that information, every detail of what you were, can never be truly destroyed. Yet if the black hole evaporates completely, where did you go? Did the record of your existence vanish with it, breaking a law the universe is not supposed to break? This is the information paradox, and the greatest minds alive still cannot fully agree on the answer. The leading idea is haunting. Perhaps you were never fully swallowed at all. Perhaps every bit of you was smeared across the horizon and, over eons, carried back out into the cosmos in that faint dying glow, scrambled beyond recognition, yet never erased. If so, the black hole did not destroy you. It only kept you, encoded in shadow, until the universe was ready to let you go. Nothing that falls is ever truly lost. It is only waiting, at the edge of the dark, to become starlight again.